All right. Hello, Senior Math. Welcome back. Today we are reviewing Z-score in preparation for our assessment, which will be on Friday of this week. All right. So things that will show up on your assessment on Friday. So finding the probability of an event using Z-score, which was just our traditional Z-score given our information, using Z-score backwards to find an event with a certain probability, and then creating a 95% confidence interval from a sample data. So we're going to review over these three topics. In your review, it sort of breaks down this first piece into two. So remembering how to use that table, remembering how to calculate just the Z-score with the formula, practice both of those as well. All right, so starting off with find the probability of a certain event using Z-score. So we had three kind of steps in this. Step number one was to use the formula to turn that piece into the Z-score. This is the second part of your review. So you take the x, the number given to you, minus the mu, which was your average, your mean, divided by the standard deviation, and that gave you your Z-score. You then looked up that Z-score on your normal distribution chart, which is this big chart that we're pretty familiar with at this point, which is the very first thing you're doing on your review. And then you had to determine which of the situations to use. Are you looking for less than a number? Are you greater than a number? Or are you in between two numbers? Because that will determine your situation. If you were less than, you just use the answer from the chart. If you were greater than, then we did 1 minus the answer from the chart. And if we were in between those two numbers, we would take the second larger answer, and minus the first larger answer. So that was our normal distribution that we were looking at. So let's look at an example of this. So a newspaper recently polled a small community and asked the citizens their opinions on a politician on a scale of 0 to 10. The average score a citizen gave was 5.8, with a standard deviation of 1.4. Find the probability of these different events. So a citizen gives a score of less than 3. So we're looking for the probability of X, the result given, is less than 3. So the first thing we need to do is we need to change X into Z. We need to turn it into a Z-score. So let's figure out what the probability that Z needs to be less than in order to calculate this. So we're going to take 3, and we're going to minus our mean, which we said an average score of 5.8, and then divide by the standard deviation, which we were told was 1.4. So 3 minus 5.8 divided by 1.4. This gives us, if we plug that into the calculator, it gives us -2. So we know that Z needs to be less than -2. And in order to calculate Z, because it's a lesson, I just need to use the value for my chart. So I'm going to pull up my chart. I'm going to find -2 or -2.00. And I get 0.2275. 0.02275. So that was our probability that someone gave less than a 3 as their answer on this thing, which was a little bit. It's not too likely. There's a chance, but it's a small chance that someone's going to say this politician was less than a 3. Let's see our probability that someone gives a score between a 7 and a 10. So the probability that 7, not 2, 7 is less than X, which is less than 10. In order to calculate this, we have two numbers that we need to find the Z-score of. So we need to go between both of these two numbers. So I'm going to start with 7. So 7, extra little tail on 7. I don't know why I keep doing that. 7 minus 5.8. We got to turn this into a Z divided by 1.4 gives us 0.86. So we know our probability is going to be 0.86 is going to be the lower value, but then Z has an upper value as well. So let's find that one as well. So we're going to do 10 minus 5.8. We're going to use both those numbers. We have to do it with both of them, divided by 1.4. If we plug that in our calculator, we get just 3, or 3.0. So we need to find 3 and 8.6 in our Z-score table. Now, because it's two values, we're going to take that second value and we're going to minus the first value first. So let's find that second value. Let's find 3.00. So go into our positive side of our Z-score table. We find 3 down here at 0.99865. So this is equal to 0.99865. And then we're going to subtract our smaller number, which was the 0.86. So I got to find 0.8 which is right here, and then 6. So 0, 1, 2, 3, 4, 5, 6. So 0.80511. So 0.80511. If I type that into the calculator, I get 0.19354. 0.19354. And that would be our probability of a citizen giving a score between 7 and 10. So more likely there's a chance for them to giving a higher value than there is for a lower value, because only 3% of citizens gave a number less than 3, but only 2% of citizens gave a number less than 3, but at least 20% of citizens gave a number between 7 and 10. All right, so using z-score backwards was another thing that we talked about. This is what you did last Wednesday when I was not available. All right, so using z-score backwards to find the event of a certain probability. So the steps we do is to first determine which situation we're using. So there's kind of a few situations. There's a probability that z is going to be less than a number, z is going to be greater than a number, or z is going to be in between two numbers. That's kind of the same situations that we were looking at on the last one. Those 3 different situations. That's what we have to look at today. So it's helpful to use a normal distribution chart or like a normal distribution curve to kind of like map out those numbers that you need and those percentages. So if that's helpful for you, that's what I would do to assist you. That's what I would do in these examples. Step number 2 is use the probability to determine the z-score from the table. So we have a couple of common probabilities that we use over here. So the common probabilities that we use are if there's 5 and 95%, these numbers are negative 1.64 and 1.64 respectively. 10 and 90% are another set of common probabilities that we have to find, which is negative 0.28 and 1.2, or negative 1.28 and positive 1.28. So those are just some common numbers. Those are, I think, the only ones I will use today, and the only ones that are on the review. But it's just helpful to have those common probabilities. And then after that, once we figure out which number we need to use, once we figure out what the z-score is, all we have to do is multiply by the standard deviation and add the mean. I had you kind of like solving algebraically, but essentially it's always the same steps. You multiply by the standard deviation, you add the mean, and you're done. So let's see some examples of these. So a restaurant serves an average of 300 customers. It's an average of 300 customers a day with a standard deviation of 23 customers. The restaurant wants to know greater than what number of customers will they serve 90% of the time. So if we create a little curve or a normal distribution curve, like I was saying, that's a pretty bad normal distribution curve. We'll pretend. We want to know greater than what number will they serve 90% of the time. So we want to figure out what number are they serving 90% of the time. So this upper value is the 90%. So this is 90%. I need to know what number is greater than that. Well, because our z-score table always tells us less than values to the left of it, that means this value to the left is only 10%. So what is my 10% on my z-score? I can look it up on my table, or I can look over here. My common z-score of 10% is going to be negative 1.28. So this number right here is negative 1.28. That's my z. So z equals negative 1.28. All right, so now that we know our z-score, all we have to do is multiply by the standard deviation and add the mean. All right, so my standard deviation that I need to multiply is 23, add a mean of 300, so I'll do negative 1.28 times 23 plus 300, and this gives me a value of 270.56. So 90% of the days they will serve greater than 270.56 customers at this restaurant. Let's look at another example. Between what 2 numbers will the customer serve 90% of the time? So between 90% of the days, what are they serving? So if we think about this curve, this is the central 90% that we're looking for. So we know the central value is 90%, not just the upper 90%, but we're looking for the central 90%. Which means that 10% that we have left over is split between the upper and lower values. So this is half of the 10%, which is 5%. And this is half of the 10%, which is 5%. Well, what are those two values going to be? So this lower 5%, I know 5% relates to negative 1.64, and this upper 5% is going to be my 95. So this is negative 1.64 and positive 1.64 are going to be those two values for my central 90%. So now that I have negative 1.64 and positive 1.64 as my two values, I know all I have to do is just add the standard deviation or multiply by standard deviation and add the mean for each of these. So I'm going to multiply by 23 and add 300 for both of these results. And these are going to give me the two values between what two numbers the customers will serve, or between what two numbers the restaurant, what two numbers of customers the restaurant will serve 90% of the days. So if I do both of these, I should get the lower value is 0.2 or 262.28, and the upper value is 337.72. So 262 customers is the lower value of customers they should serve 90% of the days, and the upper value of customers is 337. So between 262 to 337 customers would they serve 90% of every day that this restaurant is open. All right, last little piece. Creating 95% confidence intervals. 95% confidence intervals was pretty easy. All you had to do was you had to figure out what was the average plus or minus 1.96 times the standard deviation divided by the square root of n, which was the sample size. So we had the mean, or the average, the mean, the standard deviation, and the sample size. So this told us, given a small sample set, given a small group of values, can you find the average of the entire population? So given a group like a classroom, if you find the average of a classroom, can you find the sample, or can you find the mean between what two numbers would that mean be for the entire class? So just one classroom versus the entire graduating class or something like that. And we always used this formula right here, which was pretty simple. But we had to find two values. So a kindergarten class of 27 students had all of their heights measured. The mean was 39 inches with a standard deviation of 2.5 inches. Create a 95% confidence interval for the mean height of all kindergarten students. So that we're taking one class of kindergartners and we're using these to estimate the mean of all kindergartners. So we know it's x plus or minus the mean, or sorry, plus or minus 1.96, I apologize, times the standard deviation divided by the square root of your sample size. All right, so x we know is our population, or sorry, our sample size mean, which we were told was 39 inches. So we're going to do 39 plus 1.96 and 39 minus 1.96. We're getting two results because we're finding between what two numbers is this mean. Times the standard deviation, which is 2.5, and then divided by the sample size, which is the number of people we tested, which in this case is 27 students. So divided by the square root of 27. And then this would be our value. So 39 plus 1.96 times 2.5 divided by the square root of 27 gives me 39.94. And then 39 minus 1.96 times 2.5 divided by 27, the square root of 27 is 38.06. So pretty much between 86 to 40 inches, roughly between 86 to 40 inches is our sample size, or should all kindergartners be based off our class kindergarten. So we're 95% confident that all kindergartners are going to be between, the average of all kindergartners should be between these two heights. And those are pretty much the three things that show up on your assessment on Friday. We're gonna have some time to review this, ask questions. Once again, the first part of the review is very simple, basic stuff, just using that Z-score formula and then looking up the tables from the distribution chart. That's pretty similar. That's pretty easy. Those are like the first 6-10 fast questions, and then the word questions after that is actually using these three things. But that's your stuff. Let me know if you have any questions, and have a great rest of your day and your assessments on Friday.